In this video, we're going to take a look at some assembly level features in SolidWorks that can help you work more efficiently and validate your designs. Assembly patterns allow you to duplicate components within your assembly without the need to manually insert and mate each instance. The two most commonly used pattern types within an assembly are linear components pattern and circular components pattern. Linear components pattern creates copies of a part or subassembly in one or two linear directions. The distance between each pattern instance can be defined along with the amount of instances. Circular components pattern repeats components around a central axis or cylindrical face. You can set the angle, the number of instances, and the rotation direction of the pattern. Let's work through an example of a linear components pattern. I've already added one mounting tab to this base plate. I need two more of these in a straight line along the front edge of the plate. To create the pattern, I'll go to the Linear Component Pattern tool on the Assembly tab. First, I need to define the direction, and I can do this by selecting an edge on the base plate that runs in the direction I want the tab to follow. Next, I'll select the component to pattern, which is the tab. And finally, I'll set the spacing and the number of instances. The number of instances includes the original component being patterned, so you should enter what you want the total number of components to be. Once confirmed, click the green tick to accept. Now let's look at a circular pattern example. In this assembly, I've got a single gusset positioned between the cylinder and the base plate. I want two more of these spaced evenly around the cylinder to add some more bracing. In the Circular Components Pattern tool, I'll pick the outer face of the cylinder as the direction and then choose the gusset as the component to pattern. The angle needs to be set to 360 degrees, and the equal spacing tick box needs to be enabled, which ensures that the spacing is equal around the cylinder. Once applied, the three gussets are evenly distributed. Because the initial gusset is mated into place too, no additional mates need to be added. Now that we've added a few components, it's important to check that everything actually fits together correctly, and that's where the interference detection tool comes in. To check for overlapping parts, go to the Evaluate tab and select Interference Detection. Here's how it works. You can run interference checks on the entire assembly or just a selection of parts. When you click Calculate, SolidWorks will show a list of all interfering parts. You'll see visual previews of the interferences, and you can click through each one to investigate. You can see from the list that we have a number of interferences, and they are all between the base plate and the gusset. This suggests that there is an issue with how the gusset was initially mated to the plate before the pattern was added. Let's check this. I'll come out of the interference detection tool for now and look at the mates for the first gusset. You can see that there is a distance mate. This is set so that the bottom of the gusset sits below the top face of the plate, creating an interference. If I change its mate to be a coincidence instead, that should fix the problem. To verify this, I can run the interference tool again, and we can see that now there are no interferences. So now you've seen how assembly patterns can speed up repetitive tasks and how interference detection can help ensure that everything fits and functions correctly. These tools are essential for building efficient, functional assemblies, especially as your projects become more complex. And that brings us to the end of this video and the end of this assembly mini-series. And if you need to create marketing material and assembly instructions, why not try Cadasio? Turn your SolidWorks files into interactive 3D presentations that you can share online. Sign up today and try for free at cadasio.com.